In this section, we are going to evaluate functions. You've done this all along when we're evaluating expressions, but now we're looking at functions. And when you think of functions, we're now saying f of x instead of just y. So you're usually used to seeing like y equals 3x plus 2. Now we're replacing that y with f of x. They mean the exact same thing. We're just plugging something in for x to then solve. So we can look at the side here. It says f of negative 3 means negative 3 is your input, and you're going to plug in for x. We're not looking at this today, but if it said f of x equals negative 3, that means your y equals negative 3, and you're actually solving for x. But we're only going to look at the beginning steps. So replacing y with f of x is called writing a function in function notation. So for example, if f of x equals 2x minus 3, we have to find the following. So we know f of x equals 2x minus 3, and we know f of x, negative 2 is our x. So I'm just going to rewrite this with the actual function connected to it. I replaced x with negative 2, so I am also going to replace it over here. And now it's just solving using order of operations. So 2 times negative 2 is negative 4. And negative 4 minus 3 is negative 7. You could write this as your x, comma y, because it's a function, so it could go on a graph. You could also write it as negative 2 is equal to f of negative 2. I know that's confusing, but that comes up on your Imagine Math, so I just wanted to show you. But let's try another one. F of x equals 2x minus 3. But here I'm just replacing it with 7. So I'm going to do the same thing and get 14 minus 3, which is 11. So I could plot that point at 7, 11, because 7 is my x, and when I solve, I get my output of y. Alright, sometimes you can replace it more than once in the equation. So we have a function, it's a quadratic with a squared, which is completely fine. I'm replacing every x I see with that negative 3 that comes right here. Negative 3 squared is a positive 9. Negative 3 times negative 3 is also a positive 9, plus 5. 9 plus 9 is 18, plus 5 is 23. That coordinate point would be negative 3, 23. Go ahead, try it with 5 if you want. I'm going to work through it so you can pause the screen and come back to see your answer. Replace every x with 5. 5 squared is 25 minus 15 plus 5. Your answer should have been 15. You could also write it as a coordinate point like that. Alright, the last examples are the exact same, so I'm going to skip over the first two. Look at the second two. But all you need to know is sometimes they're going to give you the two different functions in the top. It's allowed to say f of x and g of x. It's just like everybody in the classroom has a different name. You're not all going to be f of x. You're not all going to be Joe or Alyssa. You're going to have different names. So same thing here. This one has the name of f of x and this one has the name of g of x. So wherever we see an f in the front, we're using the f of x function. Same thing here, f of negative 2, so I'm using the f of x function. So when there's a g in the front, I'm using the g of x function. G in the front, I'm using the g of x function. So just so you can see, we have 3 to the x minus 3. I'm going to do the same exact way. I'm just going to replace my exponent there with the number inside. Anything to the 0 power is 1. 1 minus 3 is negative 2, so your final answer there is negative 2. Same thing here, 3 to the 4th. 3 to the 4th is 81, and 81 minus 3 is 78. Alright, if you have any questions, stop by office hours.